Alright, here are notes for lessons 3-4. We are going to be obviously looking at triangles, and we are going to categorize triangles. This first row here is classifying the triangle by the angle measurement. And so acute triangles has all acute angles, which of course would mean less than 90 degrees. If we have all three angles less than 90 degrees, acute triangle. A right triangle has one right angle. The other two angles would be acute, but the fact that it has one right angle makes it a right triangle. Obtuse triangles has one obtuse angle, more than 90 degrees. Equal angular, equal means equal, angular means angles. Equal angular triangle has three congruent angles. And we will see in a moment that each one of these angles is going to be 60 degrees, 60 degrees, 60 degrees. You're never going to see a triangle that's 50 degrees, 50 degrees, 50 degrees. If you have an equal angular triangle, it has to be 60, 60, 60, as we will see in a moment. This next row here is classifying triangles by the length of their size, by the side lengths, okay? So we're not really caring about the angle measurements. We're talking about the side lengths. Equilateral, equal means equilateral side. Equilateral triangles has three congruent sides. So tick mark, tick mark, tick mark. It could be 3 inches, 3 inches, 3 inches. Isosceles triangle has two congruent sides, and you can tell by the tick marks there. And a scalene triangle has no congruent side lengths. So if you measure out the side lengths, this might be 7 inches, this might be 6 inches, this could be 5 inches. And obviously none of those match. Okay, let's go into the bottom row here where the theorems are in play. Let's go with this middle one. This is the most important theorem here. The sum, adding the measures of all the angles inside the triangle, is 180 degrees. So angle A plus angle B plus angle C will always equal 180. Whether you have an acute, obtuse, or right, whether the triangle is small, whether it's big, you will always add up the angles, will add up to 180. Now, you could have a bigger triangle, but all three angles still add up to 180. What makes the triangle bigger is not the angle measurement, because this angle could be the same as this one could be the same as this. It's what makes this triangle on the bottom bigger is the side lengths. So don't get confused between angles and sides. That's really important. Okay, these next two are related to each other. The first one is definitions, and then the second one here is the actual theorem based on this definition. So, exterior angles and remote interior angles. Well, there are angles inside a triangle. Those are called interior angles. And the angle outside would be exterior. So like this angle outside the triangle, angle 1 here, is called an exterior angle. And then there are obviously three angles inside the triangle, but the word remote interior. If angle 1 is the exterior angle, there's two angles that are considered remote interior angles. Although there might be three angles in the triangle, based on this outside angle 1, these are the two that are farthest away on the inside, 2 and 3. Okay, and there's going to be a theorem based on exterior and remote interior angles. Here it is, last box here. The measure of each exterior angle of a triangle equals the sum, add, of the two remote exterior angles. So in this picture, angle 1 on the outside, which is an exterior angle, is equal to 2 plus 3, the remote interior. And that is it.